Today we're going to finish 6.3, medians and altitudes. And today we're going to focus on altitudes because in our last video we focused on the medians. So let's scroll down, or you turn to the page that has the definition for altitude. And hopefully you're familiar with the word altitude. Altitude is really another way of saying the height. And think about when somebody takes your height. They ask you to stand up straight, or in other words, they ask you to stand up perpendicular to the ground. So the altitude of a triangle is really the perpendicular segment. I'll use the perpendicular symbol. From a vertex to the opposite side or to the line that contains the opposite side. So there's two ways to look at this, and it really depends on the triangle that you've been given. In the first triangle, it's pretty straightforward. I can draw an altitude from the vertex here at the top to the opposite side by making a perpendicular line segment. So my altitude here is this segment. I'll highlight altitude with yellow. However, what if it's not so straightforward? For example, let's say that I have maybe this really obtuse triangle. Well, it's not really so straightforward where the altitude is. What I can do is I can extend that bottom base. Maybe I'll use a dotted line to do that. And then I can draw from the vertex at the top here, I can draw a perpendicular segment coming down and meeting that. And that would still, if I found that length, that would still be considered the altitude. It is the height. Now, another center of triangles is going to be the point of concurrency of the altitudes. So the orthocenter will be our point of concurrency of the altitudes of a triangle. Just like the centroid was the point of concurrency of the medians of a triangle. All right, so let's find the equation of the altitude of a triangle, and we'll follow the steps that are given. So there are 4 steps to doing that. You've done this before, you just haven't really applied this to the altitude. So down here, we're going to see that we have a triangle EFG with vertices E, F, and G, and we'll find the equation. So we're going to find the equation of the altitude GH. So let me start off by plotting these points. You're not always going to have to plot the points to see what's happening, but it's a nice thing when you're first learning to do this. So point E is -4, 5. Point F is 2, -10. And point G is going to be off this a little bit, so -15, -3. Let's just assume it's about here. And I'm really just doing this to get an understanding of what this looks like as an image. All right, so they told us that our altitude would go from G to H. So an altitude, again, goes from a vertex to the opposite side and is perpendicular. Now, I'm not really sure where that's going to be, but I do know that H would probably have to be somewhere on EF where I could draw maybe a perpendicular angle. I'm not 100% sure where that's going to be. We're going to find out. All right, so we are going to, first of all, find the slope of the segment that the altitude will intersect. So which segment does the altitude intersect? That is correct. It intersects segment EF. So I need the slope of segment EF. So using points E and F, I'll do the change in the y's over the change in the x's. Well, that's really, let's see, 2 minus -4 is really going to be 2 plus 4. So it looks like I end up with a -15 over 6. Both of those can be divided by 3, so I will reduce it to a -5 halves. So now, step 2, you want the perpendicular slope, and this will be the slope of the altitude. So the perpendicular slope would be the opposite reciprocal, so it'll be a positive, and we flip it, so 2/5. I have a misprint in my handout, so let's fix that to slope. So step 3, use the vertex and the slope to find the y-intercept. So I am using the vertex, which is -15, -3, and the slope to find the y-intercept. So what they're saying is, do an equation that is the equation of a line. Use the slope that we just found out, and then also use these points for x and y from G. All right, so I'm going to plug in, let's see, I think first I'll put my perpendicular slope in there. Then I'll go ahead and plot or plug in the points, the coordinates for G. So I'll have -3 equals 2/5 times -15, because that was my x, plus b. And this allows me to find my y-intercept of b. So let's see, we can simplify. 5 goes into -15, -3 times. So that gives me a -6 plus b. We'll add 6 to both sides. B is going to equal 3. Okay, so that was step 3. And then step 4 now, I can write the equation for GH. Now, I didn't mark H on my line here, but that is actually my altitude. So let's see. GH, that equation will be y equals, and I'm just going to go and plug this b right back up into here. So I'll have 2/5 x plus 3. So I don't think I made my line, truly my line probably should have gone something more like this, so that eventually it's hitting a y-intercept of +3. But that's the equation of the altitude.